Hello everyone, I am Dr. Navneet Kaur from Department of Computer Science and Engineering, SIRT College, Bhopal. Today I'll be taking lecture on subject computer network, and the topic which will be discussed in this lecture is variable size framing. Now first, what is framing? The data link layer, which is this layer 2, it needs to pack bits into frames so that each frame is distinguishable from another. Now, our postal system is a common example of framing in which a letter is inserted into an envelope, and this envelope separates one piece of information from another. And this envelope serves as the delimiter. Now, here we will discuss in detail variable size framing and also the introduction of the fixed size framing. Now, what is fixed size framing? In fixed size framing, there is no need for defining the boundaries of the frame. The size itself can be used as the delimiter. Now, in variable size framing, the delimiters are defined at the beginning and the end of the frame so that each frame is distinguishable from another frame. Now, variable size framing, it follows two approaches, character-oriented approach and bit-oriented approach. Now, first, we will see character-oriented approach. Now, this is the data which is obtained from upper layer, which is the network layer, and this data has to be communicated to the sender. Now, when this data is received at the data link layer, this layer adds header and trailer to this data. Now, in variable size framing, which follows character-oriented approach, 8 bits, that is 1 byte, is added for defining the beginning and the ending of the frame. And this group of 8 bits or 1 byte is known as flag byte. Now here we can see that this data is received from upper layer. Now usually this character-oriented framing is popular when only text is exchanged by the data link layer, because the flag could be selected to be any character not used for text communication. Now, if we are transmitting information such as graphs, audio, and video, there can be possibility that in the data obtained from upper layer, we can get a byte which is similar to the flag byte. Now, if this data is received by the receiver, then it can be misinterpreted as the end or beginning of the frame. Now, to avoid this problem, one extra byte, which is called ESC byte, is added before the flag byte. Now, if the receiver encounters this escape byte, then it automatically interprets that the next byte, which is flag byte, it does not represent the end or beginning of the frame, but it is only a part of the useful information, that is the data. Now, if in this data part, if there is a collection of 8 bits, that is 1 byte, which is similar to the escape byte, which is ESC byte, then also the layer, it adds one extra byte, which is the ESC byte before the ESC byte, so that when it is interpreted at the destination, this ESC byte should not be interpreted as the byte which is distinguishing this flag byte, not as the end or beginning of the frame. Now, when this is here in this example, we can see that this data, it has one flag byte and ESC byte. That is, there are two 8-bit collection, which is similar to the flag byte and the ESC byte. Now, to distinguish this flag and ESC byte from the delimiters, one extra byte ESC byte is added before these 2 bytes. Now, this frame is sent, and when this frame is received at the destination, the extra 2 bytes ESC bytes which are added before this flag byte and ESC byte, they are removed from the data load. Now here, when this frame is received by the data link layer at the destination, this header and trailer are removed, and also the flag bytes which are acting as a delimiters are also removed, and the useful information is obtained. Here we can see that this ESC flag which is added before these flag and ESC bytes are also removed, so that this can be interpreted as the data which is to be communicated to the upper layer. Now, this process in which one extra byte is added before the flag or ESC byte is known as byte stuffing. And at the receiver end, when this extra bytes are removed, it is called byte destuffing. Now, here byte stuffing, it is the process of adding one extra byte whenever there is a flag or escape character in the text. Now coming to the next approach, which is bit-oriented approach. Now in bit-oriented approach, the flag, the collection of bits, they are acting as a flag bits which act as a delimiters. Now this flag bit pattern consists of the bit pattern which is 0, and then we have 6 number of ones, and then we have 0. Now when we obtain data from the upper layer, the data link layer adds header and trailer, and also flag bits at the beginning and the end of the frame which act as delimiter. Now, if suppose we obtain a data in which we have a pattern which is similar to the flag pattern, in that case, to distinguish so that the receiver does not mistake the pattern for a flag, here one extra 0 after 5 ones are stuffed here. Now here we can see, suppose this is the data which is obtained from the upper layer. Here we have 3 zeros, and then we have 7 ones, then we have 2 zeros. Now this 0 and 6 ones, they should not be interpreted as the flag bit pattern. Here after 5 ones, 1 0 extra 0 is stuffed. Now, again here we have 5 consecutive ones. So 1 extra 0 is again stuffed after 5 ones. This is known as bit stuffing, which is carried out at the sender end. Now when this frame is received at the destination, this extra 0 is removed and the useful data is recovered. Now the removal of this extra 0 is known as bit unstuffing. So here we can say that bit stuffing is the process of adding one extra 0 whenever 5 consecutive ones follow a 0 in the data, so that the receiver does not mistake the pattern 0610 for a flag. Now this is all for today's lecture. Now in next lecture, we will discuss about the flow control and error control, which are the useful functions of the data link layer. Thank you.